So, good evening, dear students. Welcome to 1T sessions. How's you all? So, my dear friends, as you know, today is our first session for this program. So, dear friends, today we are here. Okay, sorry for the interruption. So, welcome to the 1T sessions. I am Jinu Gupta here to teach you mathematics. So, today, firstly, we will think what we are actually going to do. So, ready all? Great. Okay, so sorry for the interruption. So welcome to Avanti sessions, my dear friends. Hope so I'm audible to all, right? And my screen is visible. So firstly, let me introduce Avanti with you. So this Avanti sessions is started by Mr. Akshay Saxena, an IIT alumni in 2010 with the support of Pan IIT alumni. So this is the organization which is there just to help students who cannot afford their education, right, dear friends? So definitely your dream. What's your dream? IIT, yes or no? So all of us, we are having a dream to go to IIT for our further studies at engineering. So ready? So let me introduce why we are here. Why we are here in Avanti and what we are going to do. So firstly, we provide you. We are here to help you to get into college with, we provide you academic coaching, we provide you awareness regarding various career opportunities. That means if IIT cannot be done, then what we can do, right? Next, if we are getting admission into a good college with good course, we also provide scholarship support for them. Yes, I guess it's clear. Then if we are providing all these basic requirements to you, then what we expect? As a teacher, what I expect that you must have a basic knowledge. I'm not saying you must have 100% knowledge of class 11, but I'm just saying you must have basic knowledge of class 11 syllabus. Yes. Then you must be available just before starting of the class. You must be there. You must be in the good connectivity. And if you're in a good connectivity, definitely, then what I also assume you definitely complete your homework, which will be assigned by me, right, dear? And definitely one more thing, all of you definitely ensure that you must attempt your test with full honesty, right? Then you must analyze your test. Why we are getting less marks, in which portion I'm getting less, in which subject I'm getting less marks, so that I can work on that and can cover up with my mistakes, right? And one more thing, most important, that many students lack in this, that you must not never hesitate to ask your doubts. Always ready to ask your doubts. Don't hesitate. If I ask my doubt, then what other will think? Will my doubt be quite good to ask? Or teacher will say, oh, what have you asked? No, it's not like. Whatever doubt come to your mind that I must ask in this topic, either it's a simple question, you must come to your teacher. Right, dear friends? So what actually you can take? See, either you can go for JEE, right? If we go for JEE, then what we can do? See, if we are going for JEE, then we definitely go for engineering, right? We must go for IIT, NITs, right? Our aim is IIT. After IIT, then we will go for NIT, right? And some good universities are there. So what I can do? Definitely, if I go for IIT, then I must go for BTech, right? Then if IIT will not be there, then what I can do? I can go for a scientist line. I can go for BSc in a good college, then MSc. Then I can pursue my PhD. Then many girls want to go for a nursing. They can go for nursing line. And there is another line that is architect. Right, dear friends? How these courses, exams, what will be the exams will become for these courses? See, everyone very well know who are there that they know JEE means JEE advanced. What do you say? Firstly, our focus is on JEE mains, right? After JEE mains, if I clear the JEE mains, I must go for JEE advanced, right? If both are after that, I can go for BitSet. If JEE advanced will not be in my list, it will not come to my bucket, then I can go for BitSet. Then IISER, ISI, NES, CUT, Means for every exam, for any course after 12, which I want to attempt, I have to give entrance exam. And for that, I need a proper guidance. So for that guidance, we are here in Avanti to teach you how we can do that. I guess I am clear in these things, right? Then next, now things come to that we are here. I am here to teach you mathematics, right? Then so many chapters are there. Many questions come to your mind that in 11 there were so many chapters. Already you all have gone through your NCRTs and subjects on the internet, that there are so many topics in class 12 also. Then what we can do, how we can cover it up. So my dear friends, just have a look on this chapter wise weightage. See, we have, like today only, we are going to start with relation, function and ITF. So today we will do relations. So you can see relation and function contains one question. ITF contains one question. That means in total 2 questions. But you're saying it's a matter of only 2 questions. But thing is that relation function is that much important topic that we cannot even think, because without functions, differentiation is cannot be done, limits cannot be done, and definitely things come to your mind that calculus. Many of you thought about that calculus. Calculus almost is the biggest unit in your mathematics. It contains so many topics in only itself, and it's the most important unit. Almost it covers 1/3 syllabus of total mathematics of class 11 and 12. Isn't clear? So overall, if you want to have a look, that algebra part will come 20 to 30%. That means 5 to 6 questions will come in that. Calculus, 4 to 5 questions will come. Coordinate geometry, 4 to 5 questions. Trigonometry, 2 to 3 questions. Then vector and 3D will come 2 to 3 questions. Isn't clear? Right, dear students? So this will be the overall mathematics syllabus that is shared with you, that how much weightage each chapter is having. Right? Okay, so let's have another part. Today we are going to, as I already told you, today we are going to start with the relation, function and ITF. Agree? So as relation is already covered in your class 11, right? So relation is already covered in your class 11. Today we are just taking a relation from that part only, because you are already done, but many of you already forgotten that what we have learned in class 11 about relation. Right, everyone? So let's get started from there only, so that we can come to last part of relation very easily, very quickly, without any difficulty, with the basics of relation. Right, dear friends? So let's get started with the chapter. So very first topic before relation is Cartesian product. It's very well known to you, Cartesian product, right? So what is actually Cartesian product? Let's have a look. What is actually Cartesian product? Can you think about this? You know very well sets in class 11. Already learned that what are sets? Like set A is there. A set is there. And set B is there, right? In set A, suppose A, B, C, I am having 3 elements. In set B, I am having 1, 2, 3. Clear? And they are put in a X-shaped structure. This is a way to represent the sets for an arrow diagram. So my dear students, what other thing you can think? You can see that suppose A is connected to 2, A is connected to 3, and A is connected to 1. Right? In the same way, B is connected to A, B is connected to B, and B is connected to C, 3. Then C is connected to 1, C is connected to 2, C is connected to 3. So these connections, that every part, every input of set A is connected to all the parts of set B. This is actually your Cartesian product. all the possible outcomes that can occur. Clear? See what I can see? I can write it as Cartesian product is always written in pairs. They are called ordered pairs. What they are called? They are called ordered pair, and it is represented by A cross B. A cross B means A to B. Firstly, we will write the element from A, then from B. It means A cross B is written in a whole set, and it is written as suppose A comma 1, comma A comma 2, A comma 3. Agree? No one will write 1 comma A because 1 belongs to B, and we have to follow the pattern A to B. Clear? Then we will have B comma 1, B comma 2, B comma 3. Next, C comma 1, C comma 2, C comma 3. I guess I'm clear in this point. Cartesian product is clear to everyone? Great. Suppose now we are having a question that example, select A with the set X, Y, Z and B with the set 1, 2, 3. You have to write A cross B. So dear friends, can I expect from your side that A cross B is going to be written on your notebooks? Be quick, write it on your notebook, then we will go ahead with the next part. Just check answer with me. A to B, it means A cross B must be equals to X comma 1, right? X comma 2, X comma 3, then Y comma 1, Y comma 2, Y comma 3, then Z comma 1, Z comma 2, and Z comma 3. So answer is there, right? Clear? Okay. So its solution is there. You can have a look that A cross B can be written as X comma 1, X comma 2. And it can also be represented with this diagram, A cross B, that we already done in the introductory part. Next, must keep it in your mind that A cross B, right? A cross B is not equals to B cross A because we are talking about ordered pairs, and definitely the number is going from A to B is not having the same order as B to A. You can say even 1 comma A is not equals to A comma 1. They both are different, right? Great. So just be quick. Just write it down. A cross B, A is there, B is there, A cross B and B cross A. And just have a look at in your notebook that are they equal or not? Yes, my dear. It's done. Great. Till there any doubt? Any confusion? Okay. Next, we have some important points about Cartesian product. What are they? You already gone through that. If set A is there, 1, 2, 3 are the elements, then we have done in sets that cardinality number of elements in set A, and that is 3. In the same way, if number of elements in A set P, number of elements in set B is Q, then number of elements in A cross B, it's a simple part. N into A cross B is actually N of A cross N of B. Clear? It means P into Q. So the answer is PQ. So as per the example is there, you can see on the screen that A is containing n of A is 3. N of B is 3. So n of A cross B, number of elements in the A cross B is 3 into 3, that is 9. Right? Then, if any one of the set, like for the Cartesian product, we are having two sets A and B. If any one, either A, either B, any one of them is null set, then again, if I say A is null, then A cross B is null. Or if I say B is null, then definitely A cross B is again null. Clear? And second thing, if any one of them is infinite set, it means if A is infinite set and B is some finite set, then things come to your mind that product cannot be finished. It will keep on going till infinity. So A cross B definitely is infinite. Clear? Then there are some properties regarding Cartesian products when we are talking about three sets. This is already things done, already covered in your class 11. We're just having a quick review back or revision from that part. First property is A cross B intersection C. So what will be the cross will come to both parts, A cross B, A cross C, and intersection in the middle. A cross B, A cross C, and intersection is in the middle. Then if union is there, then same thing. A cross B, union, A cross C. Cross means Cartesian product. Right? Then A intersection B cross C. It means A cross C intersection B cross C. A union B cross C, A cross C, union B cross C. And one more thing. Just have a look it in your mind that when you are having, just think that when you're having a set of n elements, then how many subsets are possible? Can you tell? It was 2 raised to power n, right? So it means if in A cross B, as I already compared that A cross B is also a set. And if number of elements in A cross B is n, then what you will say? Its number of subsets. How many subsets are possible? It's also 2 raised to power n. Clear? It means if in the last question I ask you in this part only, how many subsets are there? So can you tell now? It will be 2 raised to power 9. Right? So it was all regarding the basics of Cartesian product that already is there in your NCERT part of class 11. Right, dear? Great. So next one is relation. When relation comes to our mind, just think one thing. What is actually relation? What we can think about relation? You're here, we are taking a class. You are a student, I am your teacher. It's also a relation. You are sitting with your friend. He's your friend, she's your friend. Then it's also a relation. You're having a relation with your parents as a mother and a father. Then definitely it's also a relation. Then it means same kind of relation is there in mathematics, but it's not there that you can say it's a mother of this question, it's a father of this question, not at all. In mathematics language only, we are having relations. Right? So what we can think? My dear friends, what is actually relation? As already you learned about A cross B, that A cross B is your Cartesian product. Yes or no? Right. So if A cross B is your Cartesian product, then what is the relation? Relation is subset of A cross B. It means whatever the relation is defined in your question, that always a part of Cartesian product of those sets. It means relation is subset and it can be equals to A cross B. Noted? Is it clear at your part? What is the relation? Right? Okay. Let me explain one more thing. If A is set, suppose say 1, 2. B is set, suppose say 2 or 3. Then a relation is defined. What is that? You have to take A comma B where A is greater than B. Here you say A is equals to B. Then what Cartesian pair will you pick? You will say must only R must be equals to only one option, that is 2 comma 2. Yes or no? Only one pair is there because only when A is 2, then only B is 2. They both are equal. Only one pair will come from the whole A cross B. Agree? So it means R is a small part of A cross B. That's why we said R is subset of A cross B. Right? So as example is mentioned there that A is A comma B, B is 1 comma 2. A comma B, A cross B already defined by you, and you know it's 2 elements, it's 2. It means total 4 elements are there, right? So what are the possible relations? Remember, what are the possible relations? That means possible subsets. Just relate it in your mind. We already learned that subsets from A cross B, and that subsets are only relations. Clear? So it means 2 raised to power n, 2 raised to power 4. It means 16, what? 16 relations are possible from this Cartesian product when A cross B is there. So R1 is A comma 1, R2 is A comma 2. So we have just taken the pairs 1, 1, 1, then 2, 2, 2, then 3, 3, 3 possibility, then all the 4, and then 1 is empty. So is it clear to you? How many relations can be possible? Total number of relations from a Cartesian product. Great. Then we have a representation of a relation. How we can represent a relation. It's not a different thing. You must remember the sets. And in sets, you already done set builder form and roster form. And arrow diagram, remember? What was a set builder form? Set builder form was like in brackets, we must define that x is equals to, let's say, 2n, and where n belongs to natural number. Remember? Yes or no? Got it? So what is roster form? Roster form means you simply, in normal language, it is said that पकी पकाई खीर, मतलब आपको कुछ मेहनत ही नहीं करना पड़ा, कोई मेहनत नहीं करी. तो what is that? That is 2, 4, 6, 8 and so on. ऐसे नंबर चल रहे हैं. इसको क्या बोलते हैं? Roster form. In just only one look, I can get the element that all even numbers are there. But in set builder form, you have to recognize the thing that n is a natural number. It is multiplied by 2. So it is set of all natural numbers. Clear? And what is it? Arrow diagram. Arrow diagram is same. 2 X-shaped structures are there and we will make the arrows. Is it clear to everyone? How we can represent the sets? Yes? Okay. Then the next part, how you can think about it. Suppose you are having 1, 2, 3 and B set is 1, 4, 9. R, we are having a relation, and what is that relation? Elements of B are square of elements of A. Clear? So in a roster form, it's clearly known that elements of B are square of elements of A. It means you are having some pair A comma A square. Right? So what I have taken? I just taken 1, 1 square, 2 square, 4, 3 square, 9. So part done. Then in set builder, we have to just polish the things. We have to just polish the things. And how can that be done? That is A comma B. Our ordered pair is there. And what is B? B is care of A. So A belongs to A set, B belongs to B set. I guess it's clear. And arrow diagram, how it can be done. Two egg-shaped structures are there, A set, B set. We will define the elements in the structure and just make the arrows. 1 is related to 1, 2 is related to 4, 3 is related to 9. Clear? Noted? Any doubt till there? Any confusion? Okay. Next, a part that used to confuse us, that is domain, range, codomain in the relation. Three things are there: domain, range, codomain. Ready? In simple language, if A cross B is there, my dear, A cross B is there, then the first set involved in this Cartesian product is called domain. Right? Second set is called codomain. Clear? And the used element of this second set are called range. Is that things are clear in your mind in simple words? If a relation is there and that is a subset of A cross B, everyone know that this notation, then you can say the set of all the elements of first set is called a domain. Then second is codomain, and the used elements are called range. Clear? So let's have an example that you are having a set A that is 1, 2, 3, 4 and set B that is 5, 6, 7, 8. You have given a relation R is defined as, and in what form it is given. If a relation is defined in this manner, 1, 5, 2, 6, 3, 7 and 4, 7 pairs are already predefined to you, then what type of representation of relation is this? Can I know? So remember, this is actually roster form. Great. So domain of this first elements of these Cartesian pairs, that is 1, 2, 3, 4. This is domain. And range is 5, 6, 7. This is range. And the full second set, 5, 6, 7, it is called codomain. Note it down. Just keep the things in your mind and once have a look and then let me know if you're having any doubt till there. So one question is there for you. Take your time to solve this question. I'm waiting for your answers from your side. Yes. Any doubt, any confusion till there? Is the question is done? Okay. A relation is defined to you that a relation R is X comma Y, where X and Y are natural numbers. And it is given that Y is equals to X square plus 3 and X must be 0 to 5. Clear? It means you are having the option for X is only X can be 1, 2, 3 and 4. So if X is 1, so R can be defined as 1 comma. When X is 1, then Y is 4. Then when X is 2, then 4 plus 3, 7. When X is 3, 9 plus 3, 12. 9 comma 12. In the next part, When 4 is there, 16 plus 3, 19. So 4 comma 19. This will be the relation which can be defined. Now you have to calculate its domain and range. So domain of the function relation will be, it will be 1, 2, 9, and 4. Yes or no? No, no, no. It must be 3 and it must be 4. So it must be 1, 2, 3, and 4. And the range for the relation is 4, 7, 12, 19. Clear? And if codomain must be asked, what will be the codomain? Then definitely you must say it's a natural number, whole natural. Clear? So, my dear friends, it's already we have done. If a set is having m elements, another set is having n elements, then how many number of elements in A cross B? That is m cross n. And we have just gone through, if m cross n means our element A cross B is having m elements, then number of relations are there 2 raised to power n. So here we are having mn. So definitely number of relation, that is number of subsets, total number of subsets in A cross B. That is actually total number of relation, and that we are having 2 raised to power mn. I guess no confusion at this part. So let's have a look. Find the number of relation from set A to set B. If A is there, B is there. So bacha party, can you see n of A is 3, right? N of B is 3. So n of A cross B, be quick, that will be 9. So number of relation, as question is asking, how many number of relation are possible? So number of relation is 2 raised to power 9. Clear? Right, everyone? Great. So till now, what we have already gone through, we have just gone through the Cartesian product of subsets. We have gone to what is relation, what is domain, what is range, and codomain. Is these 5 concepts are clear in everyone's mind? Definitely yes. Definitely you're able to recapitulate the things from your in mind that already covered in class 11. That what is Cartesian product, what are relations, what is domain, range, and codomain. If this part is already done, then come to the next part, that is relation on a set. When a relation on itself, then how it can be done? It means if a set is there, A, and it is having 1, 2, 3 elements, then A to A cross A, you need to calculate. So in this part, what you will think? You will think that these A and A are 2 separate sets, and we will make the pairs as previously we have covered. Just have a look. That relation on a set means A to A. It means you have to cover, you have to calculate A cross A. Right, dear? So let's say we are having an example that let A be the set 1, 2, 3, 4. Relation O is given by A comma B. A divides B. So what it means? It means 1 comma 1. 1 divides 1. 1 divides 2. 1 divides 3. 1 divides 4. Then 2 comma 2. 2 divides 4. 3 comma 3. 3 divides 3. 4 divides 4. Is it clear to everyone? Right? Yes. Clear? Now we are having types of relation. What are the types of relation? What we are going to cover in today's class. So my dear friends, very first one is identity relation. What I'm talking about? Identity relation. What is that actually? A relation R in a set A is said to be identity on A if R is A comma A. My dear bacha party, if you're having a set 1, 2, 4, right? Then it must have only these 3 relations with the same element only, 1, 1, 2, 2, 4, 4. Other than these, if you are having 1, 2, 2, 4 in the same set or in the same relation, then it is not an identity relation. For identity relation, only these elements. It means if a relation is there, I am saying 1, 1, 2, 2, 4, 4, and they are having 1, 2 as well, 2, 4. It means only these three are required. If any other, then these are present, then this is not a identity one. Clear? Because identity relation used to confuse us. So just keep it in mind that when only same pairs are there and all the pairs of that part are there, then it is identity. If any other pair is present rather than these same identical pairs, then this is not an identity relation. Clear? Just think over this. As we already discussed that you are having 1, 2, 3. Can you think R1 is identity relation? Yes or no? Can we think R1 is identity relation? Definitely answer is no, because it contains this 3, 1. That is only the possibility that make it not identity. In the same way, 1, 1, 2, 2 is there, but to become identity, it must have 3, 3. Clear? Okay. Then we are having universal relation. One was identity relation. Next was universal. What is that universal relation? When your relation contains each element of A related to every element of A, it means when all the possible, when simple in simple terms, what you can say when relation is equals to A cross B. What do you say? I think it's clear. When a relation is exactly equals to Cartesian product, then it is a universal relation. Clear? Right? Then we are having one void and empty relation. When we are having one void or empty, both are same name, or you can say null relation. When, just think, empty means khali, nothing is there. It means empty set. And you know, empty is a subset of every set. Remember, empty set is subset of every set. So a relation is said to be void or empty when no element of A is related to any other element. It means when you are having a relation, but that is empty and not that is belongs to A cross A. Clear? So how you can define? Suppose I'm having a set that is 1, 2, 3. Clear? Another set that is B, and I'm having that 1, 2. Clear? So what I will define, let's say I'm defining that when relation is there A cross B, and I must define A minus B is greater than 3. So what you can say? If you find all the pairs from this, you can see there will be no pair is there that whose difference is greater than 3. Can you see? 1 minus 1, 2 minus 1, 2 minus 2, 2 minus 3, 3 minus 2, nothing is there. What do you say? Right? If product is greater than 3, then what we can say? Then we must say R is an empty relation. Clear? So as example is given to you, 1, 2, 3, 4, 5 is there. You have to make the pairs and you have to find that A minus B. So you can see even that 1 minus 1, 2 minus 2, 3 minus, they are. And what will be the maximum difference? When 5 is subtracted, 1 is subtracted from the 5, that is only 4. So 8 can never be possible, dear friends. 8 can never be possible. If 8 is not possible, it means R is a empty relation, void relation. Clear? Yes? Great. Then we are having an example. Just have a look. Let A be the set of all the students of a girls' school. Then relation. If A is a set of schools of all girls, means a school contains all the girls are there. No boys is there because it's a girls' school. Then R is a relation that A comma B. A is brother of B. Is it possible that any brother of any child is in the same school? Because it's a girls' school. No boy cannot be possible. So you can say it's an empty relation. Right? I'm expecting answers from you guys. Then R2. A comma B. The difference between the heights of A and B is less than 3 meters. So what you will say? The difference between the height of two children, two students is less than 3. And it can be possible and it can be any number. What do you say? So I must say it's a universal relation. Three meters is too much. Everyone will come in that part. What do you say? If I must ask about some inches, then we can say it's not a universal. But when it's come to the meters, 3 meters means too big. Remember? And no one is there, a person who is 3 meters, right? So what we'll say? It's a universal relation because all the possible order pairs from A cross A will come to that set R2. Clear? Is the concept about empty and universal is clear in your mind? And one was more new thing was introduced, that identity relation was there. Three relation are new things for you. Because if these three things, identity, empty, and universal, three things are clear in your mind, then only we can go ahead with the next part in next session. Other types of relation. So just have a look on very important thing. You have talked about empty relation, that means contains nothing, and universal relation that contains everything. And thing come to our mind that empty relation is the smallest relation and the universal relation is the largest relation. So these extremes are called, one is smallest, one is largest. These relations are named as trivial relation. It means if question come to us and things arises what? Elaborate in trivial relation, then two things will be there. One is empty and another one is universal. Clear? And one more thing, that is the last part of today's session, that is inverse of a relation. What is that? Inverse of a relation. Very simple part. See, suppose I have written that our relation is there and it contains 1, 2, 4, 5. What will be the R inverse? Just reverse the things, that 2, 1, 5, 4. And you can think about that when domain become range, range become domain. Just reverse the pair, each and every pair of the relation. See, if A and B are two sets, R be a relation from set A to set B, then inverse of R is denoted by R raised to power -1, and its relation become B to A. If we are defining A to B, then it will define B to A. Clear? Let's have a question on that part, and that is, let A is equals to 1, 2, 3. B is equals to A, B, C, D. And R be a relation 1A, 1C, 2C, D, 2C. Then what we can do? R is already defined to you. Just have a look. You can write over there. What is that? 1, A, 1, C, 2, D, 2, C, right? And when comes to us that R inverse, we need to calculate. Just reverse each and every pair. It will become A comma 1, C comma 1, D comma 2, C comma 2. So what will be the domain for the first set R? So what will be the domain for R? It will be 1 and 2. And what will be the range for this A, B, C, D? A, C, D, right? And then what will be the domain for R inverse? It will A, C, D. And what will be the range for R inverse? It will be 1, comma 2. Is it clear to everyone? Till there, is it clear? So this was all about this today's session. In the next session, we will cover the next types of the relation, that is reflexive, transitive, and symmetric. Yes. So we will just meet in the next session. That will be tomorrow. Till then, thank you everyone, and must go through all the things till there.